Hello everyone, my name is Wang Ya. I'm a doctoral student at Shanghai Jiaotong University. Today I'm very pleased to share with you my research on interpretable and adaptive AI governance framework. The submission number is DfP'25 0113. This study focuses on how to balance AI governance and innovations. To begin, I would like to talk about the current background and context that inspired this research. At present, artificial intelligence is widely applied in important areas such as healthcare, manufacturing, education, and finance. It has become a key factor in improving national strength and driving economic development. At the same time, it has also raised many discussions on topics such as transparency and trustworthiness, safety and reliability, bias, fairness, responsibilities, and privacy. In light of this, it's important to maintain a balance between AI innovation and AI governance. There are lack of clear digital definition for AI ethical principles. Some scholar has made attempts such as applying digital principles to different digital technologies. Causal model has the potential to balance AI governance and innovations. Overall, current solutions on this topic can be mainly divided into two types: principle-based solutions and practical solutions. Principle-based solution for balancing AI governance and improving innovation refers to guidance that includes policy, laws, technical standards, and corporate plans, technical manuals, and academic research programs. The process-based adaptation principle refers consciously adapt AI ethics during the technology design process. The meaning involves the development stage of technical staff. It requires technical staff to balance the technology and ethics consciously, and also requires external regulation and incentive for them. External regulation of technical staff in the process meaning includes educational standards, reward, and publishment mechanism, and public accountability. The top-down adoption principle mainly comes from government regulatory proposals. A balanced approach is that regulatory mechanisms are updated as technology evolves. This adaptability is expressed in two forms: specific regulation and uniform regulation. Specific regulation is based on the analysis of each situation. It targets and includes risk proportionate regulation, targets regulation, and interdisciplinary regulation. Uniform regulation has compatibility. First involves active participation, global and cross-field dialogue. They may still face problems such as long governance cycles, lack of key issues, delays, and a lack of dynamic tracking. balanced solution for governance and innovation to achieve a shift from principle to tools. Unlike principle-based solution for balancing AI innovation and AI governance, ethically engineered solution use technical means to balance AI innovation and AI governance. There are two called computational ethics emphasize incorporation ethical principle into the engineering design process. But there are some problems, such as inflexible, highly moral focus, complex, and slow to implement. Another problem, for example, the conflict between abstract principle requirements and specific practical applications, increase technical costs, reduce technical efficiency. But it still has some new problems, such as the balancing efficiency and ethics. But overall, the limitation of the principle based on practice-based scheme are mainly reflected in three key words: time, speed, and cost. So we should focus on time and use automate tools. But however, the black box problem of artificial network has become a widely recognized technical issue. So this paper focuses on using causal models. There are two main reasons why it can be used for AI governance. First, there are existing law and regulations that classify AI risk. Second, there is some governance experience. These factors create conditions for applying Bayesian network to AI governance. In addition, Bayesian network are issuable for AI governance because they are explainable, dynamic, and can be automated. They can trace responsibility and make causal reasoning according to risk level in law and regulations. They can also adjust the probability estimate, update decision recommendations based on new factors, showing dynamic adaptability. More importantly, they can speed up their governance cycles. From a time perspective, these three features of Bayesian network meet three current needs: AI governance. Governance needs a solid basis. Governance needs are adjusted dynamically with technological innovation. Governance needs to speed up the cycle to address potential delays. In general, applying Bayesian network to AI governance has four advantages. Bayesian network has causal traceability, and their prediction are reliable. Probabilities assess helps support decision making by regulations. But Bayesian network can be updated dynamically to meet the requirements of adaptability and dynamism in governments. Using existing AI law and regulation as input makes the approach compliant. This picture shows the basic process of autumn supervision based on Bayesian network. It specifically includes the following steps. This Bayesian network estimates the probabilities of risk in emerging technologies based on prior knowledge. On one hand, if the assessment result is positive, it includes the model is considered risky according to a Bayesian network. After experiencing a specific risk level externally, the tested model is transferred to regulatory sandbox. In a sandbox, the model undergoes a second risk verification using a series non-risk detection method configured by the government and relevant regulatory agencies. If samples are then showing a true positive, it means the regulatory agencies. If samples show if it has a risk that samples results match the Bayesian network prediction, so the corrective measure needed if the samples examined show for positive, it means the technology currently has no risk. This also indicates that the Bayesian network has a high false positive rate, and the test model the sample should be used as a specific noise example to help optimize the Bayesian network. On the other hand, if the Bayesian network assesses the risk of an emerging artificial intelligence technology as a negative, it means the model passes the buffer evaluation and temporarily enter social use. This requires the Bayesian network to have high accuracy. However, if the test model is deployed in society and produce feedback indicating a risk, it means the model is a false negative and Bayesian network previous buffer evaluation was inaccurate. If a model stability is guaranteed, this may be caused by unknown new risk type that is not including guaranteeing. This may be caused by unknown new risk type that is not including the prior knowledge of the Bayesian network. In this case, a new risk definition must be added to the Bayesian network to optimize the model. The proper model should be recalled from the social environment for technical correction. And probability conditions should be updated based on new experience. At the same time, regulatory authorities and other agencies need to coordinate with the model provider to carry out the technical correction and update the Bayesian network prior knowledge according to the new risk type. The new and no risk type should also be shared with regulatory authorities, including samples test kits to prepare for other models that may be identified as possible by Bayesian network in future. These measures help improve the precision and record the entire procession chain. So the use of Bayesian network to assess AI governance includes, but is not limited, the following steps. collect the legal and regulatory basis for AI governance and extract qualitative criteria for risk assessments. Converts the regulation authorities' experience, such as pass rate and violation frequencies, into probability tables, reflect their legal rules and their experience threshold from them to in the causal relationship of the Bayesian network nodes. Using the Bayesian network to perform probability inference and risk assessment. For example, given a probability value in for which risk level and AI belongs to provide corresponding decision suggestion based on the input laws and regulations. Overall, this model consists of three steps: identification, evaluation, decision. First, in the identification stage, in recent years, some scholar has proposed quantities scheme for ethical governance. Second, in the assessment stage, reference can be made to the EU Artificial Intelligence Act. Finally, in the decision stage, some school has given decision recommendation for different risks. So this model has three opportunities, and it's an inclusive governance pathway. It can supplement to static governance strategies, features, and it's an automatic generation of explainable value alignment. But it can be seen that the approach is automated prediction and reasoning framework that supports risk-free assignment in governance. However, this approach still has some limitations. First, some ethical judgments are hard to qualify or have regulatory uncertainty. Second, the optimizing the causal model effectively requires time and cost. Given these limitations, the approach should be seen as a tool for AI governance. Rather than a replacement, it should be noted that the paper only takes a step towards human-machine collaborative governance method, the practice framework, and the explainable and adaptive AI governance approaches are gradually improving. The causal model is not the only solution but serves as a supplement to current approaches. Coordinated the governance using multiple approaches can be better ensure a balance between innovation and governance. That's my presentation. Thank you.